Hey, so in this lecture, I'm not going to use the casting operators actually. I'm just going to use C-style conversion, and this is just to highlight the fact that programmers can convert to all sorts of types, and we need to keep this in mind when we write our classes. So in this example, this is just a silly example, but here we have an entity object, and we convert that type to an R value. Okay, so we need to always remember that programmers can convert to different types, and we need to think about this when we design our classes. So in this example, I'll just scroll up here. We have a class entity with a constructor. This will allocate a new integer on the heap. It has a default argument for that constructor. Then we have a deep copy constructor. Thus, our entity class with these constructors are from a previous example. We also have a move constructor, and then we have the destructor here, which will simply say dynamic object deallocated, or otherwise nothing to deallocate. What we are concerned with is the assignment operator, so we have the copy assignment operator. Here we check for self-assignment, so if this is not the same as the address of the other object, then we go ahead and we delete whatever the member pointer is pointing at. The member pointer is down here in the private section. It is a pointer to an integer. Okay, and again I mentioned in the constructor that we allocate an object on the heap in there. Okay, so in the copy assignment operator, again this is to optimize that assignment. Then we have the move assignment operator, and again the difference here is that the move assignment operator will have an R value reference, whereas the copy assignment operator will have a reference to an entity constant in this example. I also have that set to no except so that I don't have any warnings for that. We print out move assignment invoked. We also check if this is not equal to the address of the other object. Now this may be confusing because this is an R value reference. That is other, so the parameter is an R value reference. Now that might be confusing because how can we check for that? Because with that we are working with a temporary object, so you might be thinking, well, it's impossible for a temporary object to be assigned to this. Okay, so you have an instance of an object. How can you have an R value reference, which is the same thing? We cannot have that. That is an assumption because programmers can find ways of doing things like that. So again, if that is the case, if this check proceeds, then we can delete the member pointer to allocate whatever that is pointing at, and then reallocate the resources to this. Otherwise, we're actually going to print out, we avoid assignment to self. So again, this can be confusing because how can we assign to ourselves when what we are assigning is a temporary object essentially? Well, let's just go and look at main. Just as a recap, this is how we can do an R value assignment. This here is a temporary object. We construct entity, we pass in 55. I'm using parentheses, but you may prefer to use the list initialization. This is just a quick example. So we are assigning that to an R value reference. Okay, we can see here with the double ampersand. Okay, moving on. This is a construction. We are instantiating entity 1 here, an instance of entity, and then here we do an assignment. So entity 1, so 55 should now be stored in the heap integer that is managed by entity 1. Here, however, we are doing something strange. We are changing the type of entity 1 to an R value. So we are changing the type of entity 1 to an R value. This is now basically within this we are now saying that entity 1 we want to be treated as a temporary object. And so if I build and run this, we get move assignment invoked, nothing to deallocate, move assignment invoked, and we avoid assignment to self. So here we do move assignment. This is a temporary object, so we will use the move assignment. Here we are also using the move assignment, but we will avoid assigning to self because we are using entity 1 here, trying to assign to itself, and we are changing the type of entity to an R value. So the point of this is we should not assume that programmers will not be able to find a way of doing things. This can be difficult, but it simply boils down to not assuming things. So here within the typical assignment operator, so we have the copy assignment operator, we check for self. That makes sense. So when you overload the assignment operator to have a move assignment operator, then do the same thing. Simply check for assignment to self as well. There are often many checks that you can perform. So in Unreal Engine, for example, there are often many checks as you go through the code, and you may not understand why. There's typically a reason why you want to do those checks. We also have to consider that not all frameworks are open source, not all frameworks or libraries are open source. So in other words, the interfaces or the header files are provided, but the source code is not accessible directly. You do not have access to the implementation. So in other words, those frameworks are not always open source. And in that case, we should not assume that we know what the programmer will do with our code, so our provided classes and such. So we need to make the appropriate checks. This is just a silly example, but I wanted to remind you of the fact that we can have people do strange things with our code. In order to solve a problem quickly, we should not assume that everybody is going to use cast operators and that everybody is going to make, or that is write safe code with our provided library. So we need to make sure that we check appropriately to at least try and have the users of our code write safe code, alright? So this was just a bonus video. I hope this makes sense, and I will see you next time.